Students. So in this unit, we are discussing about magnetism and magnetic field, the properties, so how it is decided and how it will be useful, and did we have natural magnets? So all the things are we are discussing. So hope you are all understanding about this unit well. So in this session, we are continuing the properties of magnetism. So there are three properties. Already we discussed about two, para and dia, and this is a third property of magnetic materials. So this third one is ferromagnetic materials. We'll see what is ferromagnetic materials and how the materials are called as ferromagnetic. So what properties we need for that? So we are going to discuss about that. And this material, this property is based on atom or molecular arrangement that we discussed in last two types of materials in last class. So in this also, this ferromagnetic is giving the same property as like paramagnetic. So the atom or a molecule in this ferromagnetic gives a net magnetic dipole moment. So once again we are recalling the magnetic dipole moment we discussed now. So at starting of this unit we discussed the product of strength of the magnet and distance between the two poles. Do you remember? Yes. That dipole moment in this ferromagnetic material is like a paramagnetic. So in last class only we discussed about paramagnetic material. That same property is given here. But the difference is here the ferromagnetic material is made up of some small regions. That smaller regions in this ferromagnet is called as domain. Understood what is called domain here? The domain is nothing but the smaller region made by the ferromagnetic material is called as domain. So what is there in domain? In the absence of any external magnetic field, this domain's magnetic property or its direction aligned themselves in all possible directions. So there is no restriction. It aligns and by itself. Okay, this magnetic moments is depends only on by its own. So this domain aligning the magnetic direction in all the possible direction, and this alignment is caused by strong magnetic external field which we are applying on that domain or on that material. So here there are two types of properties will be given. So before that we'll see without magnetic field how it acts, what are the properties are there, we will discuss that. So without magnetic field the net magnetism of this ferromagnetic material specimen is nothing but zero. So without any magnetic external field, this domain having the net magnetization value of the particular material is equal to 0. Okay, that is given here. So we have to recall its property. The net dipole moment is like a paramagnetic. So if we understand the paramagnetic, we can understand this ferromagnetic. Then here we are using the word as domain. So what is the domain here? In this ferro itself, a lot of regions are there. Each regions are act as domain. In the absence of external magnetic field, these domains having the direction in all possible. So it is not restricted. So when we are restricting this direction, when we are applying the external magnetic field, whether it may be uniform or non-uniform. So without magnetic external field, the net magnetization of these domains of this material or particular material is equal to 0. So these things are we discussed in this ferromagnetic. And next we will see the condition under the external magnetic field. There are two processes takes place. One is the domains. We discussed now the domains having the magnetic moments parallel to the field. Okay, at the same time this domain will be grow bigger in size. This is first process. And second process, it is some other domains rotated so that they are aligned with the field, because before the magnetic field the domains having the magnetization direction in all possible direction. So when we are applying the magnetic field, it aligned. If needed, it will be rotated to align along with the applied field. So it will become parallel to the applied field. These two processes we can understand from this. So as a result, due to the mechanism, the strong net magnetism of the material is produced here. That strong magnetic field is acting in the direction of applied field. So that we can understand from these two processes. That is given clearly in this given picture, figure 3.21. And see the first part in this figure 3.21, the domains are acting in all the possible directions. See here, this is one domain. See the direction, all the magnetism is acting one direction. This is next domain, next one. See all the domains having the same direction, but when we are comparing from domain to domain, the directions are differ. So when we are applying the perfect magnetic field, see here the second diagram, all the domains, if required, it will be rotate along the magnetic field direction. The net magnetization is acting along the applied magnetic field direction. So it is understood from this diagram. And now we are applying in this second condition, when this material is placed in non-uniform magnetic field, it will give strong tendency to move from weaker to strong. How it is moving? It is moving from weaker to stronger part of the magnetic field. So then we have to keep in mind, this is the condition is happened under the strong magnetic field. Under the strong magnetic field, this has this tendency to move from weaker to stronger part of the field, and the material which exhibit in the direction of applied field are called as. So these properties are there in any material, means that material is called as ferromagnetic materials. So example for ferromagnetic materials are iron, nickel and cobalt. So these are all some examples for ferromagnetic materials. So you understood what are the properties. So once you go through this, it is very easy one. And next we will study about the properties of ferromagnetic materials. And so properties of ferromagnetic materials are, this magnetic susceptibility is positive and large. This ferromagnetic having magnetic susceptibility as positive and large. What is susceptibility? It gives, we study now definition, it gives the stronger of the magnetic field, it is stronger here, and also it is positive. The relative permeability is large. What is permeability? Is mu or no? So this relative permeability is here is large. And third property is the magnetic field lines are strongly attracted into the ferromagnetic materials when placed in a magnetic field. So the magnetic fields are strongly attracted. This third one. And fourth one is susceptibility is inversely proportional to temperature. If susceptibility increases when the temperature decreases, and vice versa for opposite temperature. So these are all the properties of this ferromagnetic materials. And next we will discuss about Curie's Weiss law. So this same we studied for last materials also, last property also. And this Curie's is explaining the property of this ferromagnetic, and from this we can say that temperature increases means the ferromagnetism also increases due to the increased thermal agitation of atomic dipole. So due to the temperature, the atoms are get temperature energy, and due to the temperature energy started to vibrate more and more as compared to the before that. So due to the thermal agitation, the atomic dipoles are increases, so the ferromagnetism properties also increases. And particular temperature, this ferromagnetic material will become as paramagnetic. So we can convert this ferromagnetic, applying the temperature, in some temperature it will convert into what? Paramagnetic. So we studied the property and what characters are there for paramagnetic in last class. And next, the temperature is known as Curie temperature. At which temperature this ferro is converting into para, the temperature is called as Curie temperature. That is denoted by the letter Tc. And the susceptibility of the material above the Curie temperature, we can define with the formula xi m is equal to C divided by T minus Tc. This is called as the relation of Curie's Weiss law. And C is called as Curie's constant, and T is temperature in Kelvin scale. And we are plotting the graph for magnetic susceptibility to the temperature that we are getting at beginning. We are having the large susceptibility. So at particular temperature of Tc, it is what? It will become a paramagnetic. So when the temperature increases, the susceptibility is decreases with increasing the temperature, and it will become almost parallel to the temperature. Along with it, we are getting the curve that we can understand from this figure 3.22. And mark question answer for this ferromagnetic material. It starts from the starting of the topic ferromagnetic material as it starts from as an atom. From it extends with these two diagrams, including these two diagrams, up to next page, property, page number 155, properties. Up to properties you mark, and in that they may ask 2 marks also. You study domain, and in Curie's waistline it will become as critical temperature. Okay, TC also be a 2 mark question. And then next you marked this 5 mark question. Yes. Next properties alone may be asked in 3 mark. You thorough that also. The next 3 mark question in this is from Curie's Weiss law, from here up to this graph. You mark this. Explain about Curie's Weiss law for ferromagnetic material. So this is maybe asked in 3 mark question. And now we'll discuss do you know, which is given here. So it is related to Keeladi. So in Keeladi, we are it is in Tamil Nadu. We are doing the research under the ground. So archaeological are researching there any of our minerals or some other old things which was used by our kings. So anything and any archaeological materials are there like that, they are searching that. So in that research, from the physics we are using magnetometer surveying. That magnetometer surveying is more helpful to find out the metal and minerals and easily present for certain distance that we can done here. And the minerals are either diamagnetic or paramagnetic or ferromagnetic in natural means. Each type are shown by the different range that we can find out with the help of magnetometer surveying. And Indian Institute of Geomagnetism in Mumbai conducted the magnetometer survey in Keeladi, and we are getting more things from the Keeladi underground with the help of magnetometer. And Keeladi has revealed through magnetism. So while seeing through the magnetometer, see the figure 1, so they shown with more color. No, so the figure 2 is that place where we are reaching that to find the things under the ground. And see the figure 1, this figure, that color is showing, that thick color is showing the materials which is present under the ground. So which can happen, we can find out with the help of magnetometer surveying. Okay, so that we can understand from this. So in this the magnetic materials are playing important role to find out the minerals which is placed under the ground, under the soil. And next, another one fact of do you know, is about the spin. So till now we discussed about the important three particles in atom, that are electron, proton and neutron. So while studying these three particles, we discussed only about the charge and where it is and how it is moving and how it is placed, and whether we can remove the particle from this atom. So that things are discussed. Here the new one are included. Spin in higher classes you may studied better than this. Here the intro is given. In second volume little bit it is added. While studying in BSc Physics and MSc Physics, you will discuss, you will get more ideas from this spin. So what is spin? So spin is not exactly in quantum mechanism. It does not mean rotation. So it is giving the intrinsic angular momentum. So does not have any classical analog. For historical reason, the name spin is retained. The spin of particle only taken in positive, but while mentioning in vector format, it will take negative. So, but all the spin will be mentioned with the positive term. For example, an electron, so the electron having the property of spin, so that only is giving the magnetic property, so that is playing in paramagnetic, ferro. So these type of magnetic materials are importantly played by the spin of the electron. So it is a main thing, is a main character to produce a magnetic field. The type of magnetic field that is based on the spin. It is not mentioning with the proton and neutron. The spin of the electron is only is called here. Once again we are recalling, the spin means, it is not meaning as a rotation, it is called as the angular momentum. Okay, it is called as angular momentum. And also keep it in your mind, there is no negative term in spin, but we are using negative only for in vector notation. Example, S is equal to half means is the value of electron spin, and the spin will orient either parallel or anti-parallel to the direction of the magnetic field. Okay, so two cases may be there. It implies the magnetic spin takes two values of electron. Half spin up means it will be a plus. If the spin down means it will be taken as minus half. The spin for proton and neutron is half, and for photon the spin S is equal to 1. So this electron spin maximum will give the, it will give the property of main property was is given by the spin of electron. And here in this comparison of type of magnetization, it is not for examination. So what we studied about the three types of magnetism is explained in a single tabulation. So diamagnetism, the magnetizing field is absent, means H equal to 0. The same thing is explained here for paramagnetism and ferromagnetism also. So what we discussed in as theory part is given in the tabulation. And see the next column, magnetizing field is in present, H is not equal to 0, and they aligned, see the diamagnetism aligned opposite to the field that we discussed in class, and paramagnetism along the field, and ferromagnetism aligned with the field. Then next property, magnetization of the material. And look at this graph, the magnetization of material is given here for diamagnetism. Then para, it started from 0 value and moving increasing, but this diamagnetic from maximum to minimum, and ferromagnetism from 0 to increasing gradually, then it will become almost flat. Then diamagnetism, the susceptibility value is negative. For paramagnetism, it is positive and small. Ferromagnetism, it is positive and large. Relative permeability, diamagnetism having the less than unity value, and paramagnetism, it is greater than unity, and ferromagnetism, this value of relative permeability is very maximum. So all the things what we discussed in as a theoretical part is given here in the tabulation. If you study, if you thorough this tabulation, you can understand easily that given theoretical part. And so it is not for examination. Even you can, if you study this, that is easy to study the remaining theory part of this previous three materials. So you mark this answer from here and up to end of this tabulation. So everything you studied, actually it is not for examination, but if you thorough this tabulation, then it will be easy to write the theory part of the three types of materials. Understood? புரிஞ்சா இது எக்ஸாமினேஷனுக்கு இல்லை, இருந்தாலும் இதை தரவு பண்ணிக்கோங்க, அதில் அந்த தியரி part எழுத ரொம்ப ஈஸியாக இருக்கும். Okay, and we'll stop today's class up to here. And today's homework, you mark this comparison of type of magnetization. இந்த டேபிளேஷன் மட்டும் ஃபுல்லாக தரவு பண்ணிக்கோங்க. தரவு பண்ணிவிட்டு உங்கள் ரஃப் நோட்டில் இந்த ஆன்சர்ஸை without seeing, you write in your in your note. Then you take photograph and send to my personal WhatsApp number. So hope you understood about ferromagnetic material and about Kilidi research, how we are using the magnetic property, and also we understood about domains and spin. அதை பற்றிலாம் புரிஞ்சிருக்குன்னு நினைக்கிறேன். And in next class we will discuss about hysteresis. Okay, thank you students.